Hello, welcome to Excel report number 2 from module 2. I'm Will Chamblee, and we'll get started. First thing was medication half-lives. We did ibuprofen with Miss Benzaib, but I chose acetaminophen. I think that's just Tylenol, Benadryl, and Adderall. Those are 3 that I just found interesting. One of the things we learned here during the half-life of medicine was infinite division. The fact that if you would take this and, well, let's take it with Adderall, and you were to just which this formula right here is just 30 divided by 2, and the next one divided by 2, and so on. If you just take this pattern and drag, it can go on forever. Although I don't think I did it right there, which illustrates the infinite division. I think if I just take it from here, yeah. And if you were to bump out the decimals, you see there's a number there, so it's not just 0. So it can go forever, which was super interesting, something I did not know. We took the half-lives, so this is 1 half-life, 2 half-life, 3, and so forth. And that's the fraction remaining of the drug left. So we were trying to calculate how many hours each half-life had. So obviously ibuprofen had 1.9, 2.5 for acetaminophen, I think I'm saying that right, 5.85 for Benadryl, and 10 hours for Adderall. We saw in these graphs, we'll get the trend line equation in a second. We saw in the graphs it was a asymptote. So it looks like this line is going to hit 0 on the vertical axis, but it never will. It'll just get even closer and closer for an infinite amount of time. You could drag this chart out as far as you wanted and increase the axis as long as you wanted, or keep this going for as long as you wanted, but it never hits 0. So what asymptote is, it's like this for all the graphs. For each graph, we also got a trend line equation. The trend line equation for this was 800e minus 0.365x, the x, x of course, being the amount of hours for the drug. And it was the same for each, although it was a slightly different equation, whether it was 800, 550, and then of course the power number changed. E, interesting number that I didn't know about either. It's like pi, it signifies a number. Where did my, I'm just gonna pause this real quick. Okay, sorry, I just lost my 5-sentence report real quick. I think we're talking about the trend line equation, which originates from this formula right here. Excel generates it for you. It helps us check the half-life of the ibuprofen, how close. You see the numbers are basically identical with a couple decimals off. That helps us interpret the graph as well as kind of check our answer here. E, Euler's number, is present. It is an irrational number like pi, and helps us get that trend line equation. This is obviously very important to know, so you don't overdose and consume medicine in a safe way. You know, if I were to say, I took ibuprofen 3 hours ago, I could know that I have 200 milligrams of ibuprofen left, just about, probably a little more actually. And that means it's 25% of it's remaining, and maybe I shouldn't take another pill just quite yet. Obviously, very helpful real-life skill to know. All right, let's talk about GM crops and health in the, GMO crops and health in the U.S. Change that real quick. Obviously, a hot button issue right now. We did these graphs for the data. For each chart, we tried to kind of recreate here. And this one, we have corn and soy, cotton, and corn, and in the years, and we see how the production has risen since. We just took the percentages, entered them in the graph, and then made a line graph here. Same here, you see some years they're not but we took glyphosate, applied to corn soil, and the number of children with autism. This is important because these sources, the first two, which our graphs load here, basically all 6 of these graphs come from basically what they were trying to do was correlate and prove causation between the amount of GMO products or genetically modified organisms planted and the certain diseases. So you have autism, deaths by intestinal infection. I believe there's Crohn's disease down there somewhere. Peritonitis, inflammatory bowel, Crohn's disease. And all these, they're trying to basically prove causation when in actuality, it's a correlation, merely coincidence. GMOs are regulated heavily by the FDA. They're safe and they're good for us in the sense that maybe they don't have better nutrients. I'm not really sure the numbers of that, but they help us provide more food for more people in the world. If I'm going to be honest, autism or what have you is much less of a danger to people than starvation and hunger, especially those in third world countries. So you see these correlations as, the number of children with autism rise, so does the GMO corn. Same with intestinal infection. As the acres are planted go up, so does the autism, rheumatoid arthritis. And then, of course, inflammatory bowel disease goes up with the corn as well, as they're trying to just kind of prove causation. Personally, I don't believe in it, but it is what it is. Again, it makes you have to, when you see these kind of graphs right here, you have to be careful and think critically, see if it's really causation or correlation, and it's important to know the difference so you can assess information and hopefully be more intelligent about your health and not believe stuff that isn't true. So you got to think critically and be on the watch for these kind of graphs. They look right, but they're not. All right, let's go on to impaired driving. Another important number. We took the stats here, we put them in, and you see we made graphs for each one, fatalities per year. We're going to look at the difference between 2018 and 2019. It's not on this graph, but you see the fatalities per year pretty much staying the same. 2018 has a little bit of a drop. Here by location, this is by year. You see 2018, 2019, it goes up, goes up, goes up. Oh man, what did I do? You see by level of urbanization, 2019, there's more deaths just per accident, but there's also way more deaths in rural roads than urban or cities and towns. I thought it was interesting, but it makes sense if you think about it. Rural roads are obviously going to have much less regulation. There's going to be worse road conditions, and while there's going to be less traffic, there's not going to be street lights at night when it rains or if it snows. Obviously, the conditions are going to be worse. Sometimes you're looking at gravel roads or dirt roads, etc. We had the fatalities by type of motorist. The drivers are obviously the highest. And again, 2019, you see the orange versus the blue is much higher. So obviously, we're not learning from our mistakes. Drivers, solely because there's more drivers on the road than there are motorcyclists or bicyclists or passengers. That's just because there's more of them. Here we see age groups 70 and over leading the charge in not a good way. This surprised me, but I guess, again, it makes sense. You look at the percent change over the years. They're all positives except for this one. It's a negative, and there's 0. Again, we're not learning. 0 to 4, that's really sad. Old people, obviously, you only have to take your driver's test once, which I think is something we could change in our country. Maybe when you hit a certain age, maybe 70, you have to start retaking the driver's test every year. It might be a little condescending to old people, but I think it would help us be safe. Gender, males by far dominating, which is what we do. And you see, again, 2018, 2019, there's a big difference in terms of change and spread. Not great stuff, but it is what it is. So obviously people aren't learning from it. We took a reaction time of adult subjects and blood alcohol. Delete that. You see the reaction time, and in fact, all right, yeah, I had to fix my histogram real quick. So we see the histogram reaction times really slow. The highest group being 2.1 seconds to 2.5. When you're making split-second decisions on the road, that's way too slow. And you see the median of 2.4, standard deviation of 0.5. Mean is not quite right. That's not okay. It's the average, which again, that becomes redundant. And see, now you see the formula there. And we get our mean, 2.16, which makes sense. The standard deviation, of course, the mean, that's C 124 to C 148. So you got to encompass the whole thing. And now I get a mean of 2.364, much closer to the mean. Your coefficient variation, which is, of course, the mean, the standard deviation divided by the mean, which gives you 0.24. There's your graph. And then we recreated this graph, which took drivers who tested positive for these drugs, and then obviously you see in the Venn diagram, some are higher than others. Really interesting stats. 17% tested positive for alcohol. And you had some really crazy combinations of cannabis, other rec drugs, and alcohol. Some of them medication, all four at 0.2%. Only two people. People really driving unsafely. And there's a question asked there on driverless cars. I thought it'd be interesting. It would solve some problems, but other problems it wouldn't solve. People obviously wouldn't all make the switch. Some of it just couldn't afford. Other people just are stubborn. And in that case, AI cars interacting with human cars or humans, and the humans interacting with AI cars scares me a little bit. Not sure how we would react to some of the movements. All right, let's zoom in a little bit here. Talking about BMI now on our fourth. See the women and the men standard deviations. For my chart, I took me and my two friends, so all of our BMIs are on the men's side because we're men. But we'll talk about the women real quick. You see the spread right here. Bigger standard deviation, so more of a variety for women than men. Men's pretty tight, actually, bottoming out around 10, 10.8, and ending around 47.92, which is a huge BMI. Our scores were 22, 26, and 20, so you see the 20, 22, and 26, all kind of in that only two deviations, all within the standard deviation range, or the confidence intervals for our respective groups. Let's see here. The BMI, of course, is your body mass index. It takes your weight and your height and your age, and it tells you how healthy the weight is. Interestingly enough, someone like me who has 22 BMI, there's only a 7.8% chance someone has a lower BMI than you. Let's go ahead and check our scores out on the graph. We had our callouts here. Can I go any lower? My word. Yes, we can. So see, There I am, and you see move the decibel twice, you get the 7.8 for the people that would have a lower score than me. And then you see the 0.2, 26% would be my friend Caleb's, and then Sean here with only a 20 BMI, he's really thin. There's only a 2.8%. So you see there's z-score right here. You can calculate the z-scores here. Right where it tends from negative to 0 is 27. For women, that should be the mean. That's how you can't tell we did it right. 27. At 27 is where it goes from negative to positive, right there, 27.7. Same for men. At 29, it should go from negative to positive. It does. That's how you tell we did it right. Earlier in the other module, we talked about the probability of being obese in America. I looked up some statistics. Healthy the chance of being healthy for women is much higher for men. And of course, in Arkansas, where 35% adult obesity rate, it's obviously going to be a lot lower of a chance for being healthy and not obese. We see the confidence interval, which is 2 standard deviations to the left and the right. Gives you 95% chance that someone is going to be inside of that confidence interval. That it utilizes standard deviation. Of course, all these numbers are interconnected. The standard deviation and the mean. Standard deviation utilizes the mean. It's really how many numbers over from the mean to the left and right it is. The confidence interval, obviously, it uses both. Okay, let's go to the U.S. budget. You see the distribution, there's an obvious outlier here, and that is the 1%. See that right here, really the top 5%. Crazy high compared to this, and the percent of income they make, which is not okay. You see on this chart, the 1% owns 35.4% of the wealth. That's an obvious outlier. It skews all the data. The means and stuff are not usable, the median. That 1%, that little blue, that's how many of them are. That's how much of the wealth they own compared to the amount of people here that own just that much of the wealth. You see it again, a better representation on this graph. The next picture. In terms of federal tax dollars, a whopping 27% to Medicare, Medicaid, 24% to Social Security. So again, you see 2 spent really to health, and then defense is 16%, and the safety net programs kind of start the decline. 2% on education obviously is important to us because we're being educated currently. What I found was the state more than makes up for that, kind of. I looked up this source right here, Ballotpedia, and it gave me some stats here for the Arkansas tax spending. I thought I had a chart for it, but maybe not. You have 14.6. Sorry, I just lost my chart there for it. You see 15% for both higher education and K-12 education. That's 30% right there. Goes to education, much higher than the 2% right here for the government. Half, it splits it half and half really, going to K-12 and higher education, which is obviously college, Arkansas Pulaski Tech. Then you have 6% going to transportation, corrections, public assistance, and then Medicaid's the biggest spender at 25%, and the other is obviously a bunch of smaller things in there. See the government spending. If we didn't have a tax system, another thing that was added to the 5-sentence list, I don't think America would have as great infrastructure, obviously. Taxes are a big part of why we have roads and bus systems and stuff like that. And I don't think America would be doing as well. All right, then on to the last sheet. Let's talk about the 5-year plan. I'm just going to scroll on over. See, I picked 3 locations: Tacoma, south of Seattle, Little Rock, and Dallas. Little Rock I currently live in. I took the average salaries here. Communications degree, so about $71,000 for Tacoma, a little less for Arkansas, and then higher because of the higher cost of living in Dallas. Tacoma's cost of living and Little Rock's cost of living is pretty similar. $5,800, $5,600. And then Dallas is 5,900. It's lower than you'd think, but that's because I'm not paying for car payments or gas in this scenario. I decided I'd use public transportation, so buses, which is going to save me some money, even though entertainment's going to be higher. You look at the budget trees here, you see I'm only paying 90% mortgage as well because I don't have a house. I'm talking apartment here. But you see entertainment's at 3%, but only 2% here. Personal care at 3%, only 2% here. Eating out is 2%, only 1% here, and the same here. I'm paying higher taxes. Repair costs and maintenance is going to be higher. The utility bill is 5%, or it's 3% here. In Dallas, I'm spending more on other things, but I have less to spend on. So that means more goes into saving, and I have a higher margin at the end of the month. That's the cost of living. So sometimes having a higher cost of living but earning a higher salary can be better for you. Other times it means you're not going to have as much as a surplus. I ended up doing a bar chart as well. Sorry, we're back. I did my little dream chart here. So I get down there. Communications degree. These are the houses and of course apartment. Bus. I wouldn't have a car. And then picture the cities. Fuel efficient cars in a truck. Just had to pick a Tacoma while living in Tacoma. Then I did my week per hours. I figured in Dallas I'd be working more because I'm making more money. So 45 hours a week, that means less sleep. And in Tacoma, Arkansas, the work is pretty comparable on the sleep as well. No yard work because I live in an apartment, allowing me more times to go out with friends. And when you live in a state like Dallas, you want to go out more. So add some hours to that. You're going to have less chores around an apartment as well. Yard work stays the same in Tacoma and a little because hopefully I'd be having a house. And then, family, friends, eating stays the same because you got to eat. Here's some charts. The big differences were sleeping, work, 27% at Dallas, 24% at Tacoma, 22% in Little Rock. Friends, 13%, well, only 11% here. Gaming in Dallas, I have less time for gaming because I'm working more, so only 10 hours, while there's 18 in Little Rock or 15 in Tacoma. So depending on where I live, how much I'm working, I have more time to do stuff. And then nutritionally, I took some guesses here where I'd be at based on where I was living. Tacoma by the sea, so you're going to eat more seafood there. Arkansas, more fried food and meat. Dallas has a better food scene, so you're going to have a more wide variety of stuff. So you see in Dallas, there's more variety there. All the charts have a bigger space, while in Little Rock, it's a little less of that. Right. 10 skip meals in Dallas because I'm working more. So you're not going to eat as much. 7 in Tacoma and 5 in Little Rock kind of goes with the work hours, basically. And so, yeah, that's Excel number 2 for me. Thanks for watching.